Hi, good morning students. How are you all? See, yesterday we have seen a rate of change. Now today we are going to see that is increasing, decreasing. This is one of the most important topic, increasing, decreasing and tangent and normal. Compulsory one question will be there. Now let us begin increasing and decreasing. You know general meaning, what is increasing? Whatever the given interval, suppose A to B. If the function is continuously increasing, that is called, you have seen cricket match graph. So suppose if it is continuously increasing, then we say increasing. If it is continuously decreasing, then we say decreasing. Suppose this is A to B. Suppose the function is increasing and then started decreasing. So means throughout this interval, neither function is increasing nor decreasing. Clear to you? Increasing means the function, whatever the given interval, between the given interval, the function should be positive. And decreasing means the function f dash of x derivative must be negative. So then we say increasing, decreasing. Suppose if there is any fluctuation between the given interval, then we say neither function is increasing nor function is decreasing. Clear? Now let us begin what is increasing, what is decreasing. Here, see, suppose let y equal to f of x as a real valued function. A real valued function defined on defined on domain, defined on its domain. Then I am taking let x1 comma x2 belongs to, this is without a derivative test, I am saying its domain. If f of x1 less than f of x2, if f of x1 less than f of x2 implies fx is strictly increasing. fx is strictly increasing. Clear? This is without a derivative test, I am saying. Now, if f of x1, which is f of x1 greater than f of x2, we are taking, that means x1, x2 belongs to this domain, and if f of x1 and x1 less than x2, x1 always, I will give you example. This, we are taking any two real number, D is a domain, for example, this is a real number. If I take any two real number, condition always x1 less than x2. Suppose if you are getting f of x1 less than f of x2, we say implies fx is strictly increasing. If you are getting f of x1 greater than f of x2, implies fx is strictly decreasing. Okay, fine. Now let us take some example. I am taking, show that the question is coming like this. Show that f of x equal to 3x minus 5 for every x belongs to R. Show that that is fx. Show that fx is strictly increasing. Now see what I told you. So I am taking let x1 comma x2 belongs to real number. Okay, fine. So if this x1 less than x2, if x1 less than x2, I am taking the condition. Now as per question, what is f of x1 implies what you need, f of x1 less than f of x2 as per definition. Am I correct? As per definition, I am taking x1 less than x2, I should get f of x1 less than f of x2. Now what is f of x1? So now I am taking the condition if x1 less than x2. Okay, fine. I need f of x1, this one, f of x1 is 3x1 minus 5. So now I am doing multiplication both sides by 3. So what I will get it at 3x1 less than 3x2. You have seen already linear inequality in class 11th. That time you have seen, suppose for example, if I take minus 5 less than minus 3. If I multiply both sides by positive number, I am multiplying both sides by positive number 2. So we will get 10 here, we will get minus 6. So inequality the same. Am I correct? It will not change. If you touch this minus, if I multiply, so here multiply by 2, positive 2. If I multiply by minus 2, what we will get here? This is 10 and this is 6. Automatically inequality will be changed. So inequality, if you multiply both sides by positive number or divide by positive number, inequality will not change. If you touch negative, either if you divide by negative number or this multiply by negative number, automatically inequality will be changed. That's why I have given you example. Clear? So as per this, here I am multiplying both sides by positive 3. So inequality remains same. Now if you add or subtract any number, inequality will not change. So as per this function, I need both side minus 5. So I am doing both side minus 5, subtracting minus 5. So that is equal to, so we are getting, this is f of x1 and which is less than f of x2. So see, I have taken x1 less than x2, x1 less than x2, I am getting f of x1 less than f of x2 implies fx is increasing. Fx is strictly increasing. Clear to you? This is without a derivative test I am doing. Another example, another example I am taking, same function, let me take, show that f of x equal to minus 3x minus 5 for every x belongs to R is strictly decreasing. Depends on the question, what they have given. What is coefficient of x or x square? That's you have to see. Now, what definition is saying? If x1 less than x2, either increasing or decreasing, you cannot, this is reality. We are taking two real number. Two real number, always the condition x1 less than x2. You cannot change increasing means less than, decreasing means greater than, that's keep in your mind. Now I am taking x1 less than x2 for every x1 comma x2 belongs to where? Real number. Okay, fine. Now, as per question, I have to prove f of x1 which is greater than f of x2, then we say as per definition it is decreasing. Am I correct? Now, as per question, what is f of x1? Minus 3x1 minus 5. So, I have to multiply both sides by minus 3. Right now, I have given example, if we multiply both sides by negative number, automatically inequality will be changed. Am I correct? Now, automatically it will be changed. That is minus 3x2. Now, if you are adding, subtracting, there is no effect of this inequality. Okay, fine. Now, I need, as per function, I need both sides minus 5. So, which is greater than my 3x2 minus 5. So, this is automatically f of x1, which is greater than f of x2. Now, I am taking x1 less than x2. I am getting f of x1 greater than f of x2. Implies fx is strictly decreasing. Clear? It is quite easiest to what? As per question, it will change. What is coefficient of x? See, without derivative, if you are proving increasing, decreasing, keep in your mind this point. If you multiply both sides by negative number, automatically inequality will change. If you multiply both sides by positive number, inequality remains the same. So, clear to you without derivative how to do increasing, decreasing. Now, using derivative test, how to do increasing, decreasing. Now, the same definition, let us start. Let y equal to f of x is a real valued function defined on its domain. Domain may be real number, whatever as per given. Defined on its domain. Then, now I am using derivative. Step number 1, find f dash of x. Find f dash of x. If f dash of x strictly less than 0 implies fx is strictly decreasing. Suppose if f dash of x less than or equal to 0, we say simply fx is decreasing function. Are you clear what is the difference between both? That is strictly less than means we use this word. Now equal to sign, then we say simply decreasing. If f dash of x strictly greater than 0 implies fx is strictly increasing function. Now, if f dash of x greater than or equal to 0 implies fx is increasing function. Clear to you? Nothing, simple, find the derivative. If it is negative, the derivative is negative, then it is decreasing. If the derivative is positive, then it is increasing. So, derivative test is quite easy. Now, anyhow, the board one question will come. That is you have to use for derivative test. That is without a derivative test, maybe 1 or 2 more question will come. Now, let me start some questions for increasing, decreasing. Now the first question I am taking, that is y equal to f of x equal to x power 4 minus 4x cube upon 3. Find the intervals where the function is increasing or decreasing. Strictly, that's understood. Anyhow, see, there are two parts. One part is show that the function is increasing. For example, another example let me take. Suppose if the question is given, show that f of x equal to, suppose if they have given to you e power minus 2x, okay, as a strictly decreasing function. One is strictly decreasing function on R, on can be function on real number on R, okay. So one is to show that the function is increasing, decreasing, another one is to find the interval. What is the difference between, you must know this is, what is the difference between these two. If you want to show any question is increasing, decreasing, then simply you find f dash of x. What is f dash of x? Minus 2 into e power minus 2x. Now by argument you say why it is positive, why it is negative. See, for every x belongs to R, what about e power minus 2x? Definitely always greater than 0. If we keep even 0, e power 0 becomes 1. If we keep 1, e power minus 2, that is 1 upon e square, that is positive. So for every x belongs to R, e power minus 2x is greater than 0. Suppose if I multiply by both sides, that is which is strictly, we will get inequality will be changed, this is strictly less than 0. So this implies we are saying f dash of x is less than 0. This implies fx is strictly decreasing function. Are you clear? One part is to show that, another part is to find the interval. Suppose the same question f of x equal to, they have given e power 3x, suppose, okay. So what would be f dash of x? F dash of x equal to 3 into e power 3x. You know for every x belongs to real number, e power 3x always strictly greater than 0. Now if you multiply by both sides positive number, inequality remains same. So we are getting f dash of x is strictly greater than 0, implies fx is strictly increasing. So if the question comes to show that, then the step number 1 is to find the f dash of x. If f dash of x is strictly less than 0, so by argument you have to say what about this f dash of x? What is the nature of f dash of x? If it is less than 0, you know this is strictly decreasing. Suppose if f dash of x you are getting greater than 0, that is only through argument you can prove it. So then implies fx is a strictly increasing function. So what I am saying, so there are two variety of questions from increasing, decreasing. One is to show that, that's why I told you what you have to do. Another one is to find the interval. Nothing else in increasing, decreasing. Now I told you how to show the given function is increasing, decreasing by argument. Okay, fine. Now, anyhow, now we are finding intervals. Now what is the procedure to find the intervals where the function is increasing, decreasing? The same procedure what you have to do, find the f dash of x. Okay, fine. What is f dash of x? 4x cube. Now this is 4 into 3x square upon 3. Okay, it will be cancelled. Now this is a 4x cube minus 4x square. Now f dash of x equal to, bring this into simplest form, 4x square is common, x minus 1. Now see, what is the procedure to find the interval? Step number 1, find the f dash of x. Now take let f dash of x equal to 0. Why we are taking 0? Find the interval where the function is strictly, the question is strictly increasing, decreasing. So equal to sign not allowed in question, so that's why I am taking equal to 0 to find the value of x. So means 4x square into x minus 1 equal to 0. So this implies either x is equal to 0 or x is equal to 1. There are two rules we are getting. Clear? Step number 1, what I told you, f dash of x. Then you should bring f dash of x into simplest form. Simplest form means factorization form. Then take the f dash of x equal to 0 so that you get value of x. Now this is we are checking real number. Real number start from where? Minus infinity to plus infinity. Whatever you are getting the value, arrange in ascending order, not 1 0. That is 0 and then 1. Clear? That is I have arranged here ascending order. Suppose if you have only one value, 1, then put it 1. If you have 2, 3 values, for example, x is equal to, you are getting minus 1, 2 and then 4, then you have to put it first minus 2, then 2, then 4. Like this, then we have to divide the interval. Clear to you what I am saying? So whatever you are getting the roots, you have to arrange the roots between minus infinity to plus infinity in ascending order. 0, 1. Now I am dividing the interval minus infinity to 0, 0 to 1 and 1 to infinity. Now see how I am dividing. Minus infinity to 0 and 1 and 1 to infinity, 1 to infinity. Now that is, I am taking between, that is up to your choice. I am taking x equal to minus 1, very between the value how to take it. X is equal to half and here x is equal to 2. Now substitute in where? F dash of x. Am I correct? That is the definition is saying. Now replace here f dash of x is minus 1. I need positive or negative. I don't want value. See, this is a 4 and this is a negative. 4 is positive, x square minus 1 ka square is positive, that is 4 into minus ka square. Am I correct? Minus 1 becomes negative. So this is a positive, this is a negative, total is negative, that is f dash of x we are getting, f dash of x less than 0, that means decreasing. Am I correct? Now x is equal to half, substitute in f dash of x. If you are not writing here f dash, simply plus minus, there is no meaning. That's keep in your mind. Now f dash of x, half, anyhow first one is positive 4, x square if I keep 1 by 2, 1 by 2 ka whole square is a positive. If I keep here 1 by 2, 1 by 2 minus 1, again we are getting negative, that is equal to negative, that is decreasing. Now anyhow the next one, x is equal to 2, x is equal to 2 if I keep f dash of x, so that is f dash of x is equal to what we are getting, that is keep x is equal to 2, first one is positive, next one is positive, third one is positive, this is also positive, that means f dash of x is greater than 0, we are getting increasing. So anyhow, that is once again see f dash of x, the question is given x power 4 minus 4x cube upon 3. Now I am differentiating 4 into x cube, that is this one is a 4 into 3 square upon 3, 3 will be cancelled. I am taking common 4x square, that is we have x minus 1. Am I correct? Now this is then f dash of x equal to 0. So x is equal to either 0 or 1. We are putting these value between minus infinity to plus infinity. So minus infinity to 0, 0 to 1 and then 1 to infinity. So in between you have to take any value, that is up to your choice. I am taking x equal to minus 1. Now substitute in f dash of x. This is positive, minus 1 becomes negative, we are getting less than 0, therefore it is decreasing. Again 0 to 1, between we are taking half. I am keeping here half ka square, positive, this is positive, half minus 1 becomes negative, this is also decreasing. Okay, now next I am taking x equal to 2, so this is positive, 2 minus 1 is positive. So therefore fx is strictly increasing on 1 to infinity and strictly decreasing, fx is strictly decreasing on where? On, that is minus infinity to where up to 1. Otherwise you can write minus infinity to 0 and 0 to 1. Clear to you? Clear to you? Okay, fine. Now let us take example. Another example. Okay, now let us start another example. F of x equal to x square into e power minus x. Find the interval where the function is strictly increasing and decreasing. Now what I told you procedure, first of all f dash of x. There are two functions within product, of course product rule. X square I am keeping constant, e power minus x. E power minus x is differentiation is e power minus x into differentiation of minus x becomes minus 1 plus e power minus x is constant, x square differentiation is 2x. Now f dash of x equal to, I am taking common element x into e power minus x, here we have minus x, here we have 2. Anyhow let f dash of x equal to 0, am I correct? F dash of x equal to 0. Now that is x into e power minus x into minus x plus 2 equal to 0. This implies e power minus x is not equal to 0. So this implies we are getting 2 value x is equal to 0 and what 2. Now where we have to put this value minus infinity to plus infinity, 0 to ascending order. Now we have that is minus infinity to 0 and 0 to 2 and then 2 to infinity. Am I correct? Now I am taking between one value x equal to minus 1. Here x is equal to 1 I am taking. Here x equal to I am taking 3. Now f dash of x that is equal to, just to check it, positive negative. This is a negative sign. This is always positive. Am I correct? Now if I keep minus 1 minus plus, that becomes positive. We are getting negative, it becomes decreasing. Clear to you how to check? Now I am f dash of 1 positive 1. First one is positive, next one is always positive. If I keep minus 1 plus 2, that is we are getting positive. So that is equal to positive, it is increasing. Now 3 I am keeping here, f dash of 3. So that is equal to, now this positive, e power minus x always positive. If I keep here minus 3 plus 2, we are getting negative, that is negative, this is a decreasing. So what is the conclusion? So this implies fx is strictly increasing on 0 to 2 and strictly decreasing on minus infinity to 0 and 2 to infinity. It is quite easiest one how to find the interval. Clear to you? Now let me start another example. Now I am taking this last example. Okay, fine. I hope so. I think you can understand what I am saying, how to find the interval. Now let us show one question, how to prove, how to show. See another example I am taking, show that. Okay, fine. Still we have seen two questions, how to prove, how to find the interval, where the function is increasing and decreasing. Here we are going to see how to show the function is increasing or decreasing. That is to show that fx is, show that y is an increasing function. Okay, fine, increasing function. What I told you, right now we have seen two examples to find the interval. What are the procedure? Step number 1, f dash of x. Let f dash of x equal to 0. Before taking f dash of x 0, you must bring that f dash of x into factorization form. Then f dash of x equal to 0, you are getting value of x. So we are talking about algebraic function. Then you have to feed the value ascending order minus infinity to plus infinity. Then divide the interval. If f dash of x is less than 0, we say decreasing. If f dash of x is greater than 0, we say decreasing. Am I correct? Now we are going to see the question, how to show the function is increasing. Already I have shown the example. Now even then, let us see. Now dy by dx, dy by d theta. We here is a variable is a theta. Now I am using here quotient 2 plus cos theta whole square. Now I am keeping 2 plus cos theta as a constant. Now this is differentiation is a 4 cos theta. Now minus and 4 sin theta is a constant. I am doing differentiation of denominator minus sin theta. Am I correct? 2 is 0, cos minus. So minus 1. Now that is equal to what we are getting here. So that is 8 cos theta and then plus 4 cos square theta and then plus 4 sin square theta. I am taking LCM here. So that is minus 4 cos theta and then minus cos square theta. Am I correct? The whole upon 2 plus cos theta whole square. 2 plus cos theta whole square. Now anyhow, now simplify this one. That is equal to 8 cos theta minus 4 cos theta. What we will get it? 4 cos theta. Now 4 cos square theta plus 4 sin square theta. If I take out 4, sin square plus cos square becomes 1. So 4 minus 4 and then what term is here? That is minus cos square theta. The whole upon 2 plus cos theta whole square. Am I correct? Now anyhow here see this will be cancelled. Now that is equal to 4 cos theta or minus cos square theta, the whole upon 2 plus cos theta whole square. Okay, fine. Now see here cos theta. See you can give your argument here only. The theta belongs to 0 to pi by 2. 0 to pi by 2 is which quadrant? First quadrant. First quadrant all tribute ratio are positive and even cos square theta value is lies between 0 and 1. Am I correct? 0 and 1. So 4 is greater than 0 and 1. So definitely this is whole square, this is always positive, and numerator is positive, positive upon positive, total is positive. So you can give argument here only. Otherwise, if you want to show more, then what you can do? Cos theta take out the common. So we are getting 4 minus cos theta. So I am writing 3 plus 1 minus cos theta, the whole upon 2 plus cos theta, the whole square. Now that is equal to, I can write cos theta into, that is a 3 plus 2 sin square theta by 2, the whole upon 2 plus cos theta ka whole square. Okay, fine. Now see, theta belongs to where? Theta belongs to closed interval 0 to pi by 2. This is which quadrant again? This is in first quadrant. This is positive, this is positive, this is positive, this is positive. You know, when theta belongs to this, all trigo ratios are positive. This implies I am writing directly dy by d theta is greater than or equal to 0. This is a closed interval, means including boundary. So pi by 2 cos 90 becomes 0. So 0 into something we can get 0 also. That's why I am writing here greater than or equal to 0. That's why the question is saying simply increasing. They did not say strictly increasing. So this implies automatically we can say y is an increasing function. So anyhow, I hope so you are clear about it. So how to show the function increasing, decreasing, and how to find the interval of the function increasing, decreasing. Clear to you? Anyhow, I can give one more example from trigonometric question also. So you have to do more practice. You take NCERT again. I am saying this time only. Take NCERT. You should be very thorough in NCERT question. Then only you can do. Anyhow, this is the last example for increasing, decreasing. Again, find the interval f of x equal to sin x minus cos x, where the function is increasing, decreasing in the interval 0 to 2 pi. Suppose if it is a trigonometric, then suppose the interval not given. Even then you have to consider 0 to 2 pi. Okay, fine. Now let us see this example. What is same procedure? F dash of x. What is f dash of x? That is cos x minus plus sin x. Am I correct? Minus is this, cos ka differentiation minus sin, we are getting plus. Now let f dash of x equal to usual procedure. F dash of x equal to 0, then sin x is equal to what we will get it, minus cos x. Am I correct? This implies tan x is equal to minus 1. Minus 1 which quadrant? You know, second quadrant, and then fourth quadrant. So you know how to write 3 pi by 4. This can be written as minus tan pi by 4, and then this can be written as tan of so which quadrant? Tan 180 minus theta, pi minus pi by 4, and then fourth quadrant tan, that is 2 pi minus pi by 4. Like this we are finding. So that is a 3 pi by 4, and then this is a tan 7 pi by 4. Okay, 5 pi by 4 and pi by 4. That is first and third quadrant. That is positive. So tan x minus 1, when we are getting, are you clear this thing? How we are getting 3 pi by 4 and 7 pi by 4? Okay, now see. So this implies what is the value of x? X is equal to 3 pi by 4 comma 7 pi by 4. Definitely both are belongs to open interval 0 to 2 pi. Now I am dividing this interval, that is 0 to 3 pi by 4 like this. However you have done in algebraic term, the same manner you have to do it like this. Okay, fine. Now I am taking 0 to 3 pi by 4, one value, and 3 pi by 4 to 7 pi by 4, and then 7 pi by 4 to 2 pi. Clear to you? Okay, don't go for number line. That is, there is no clarity in number line. That's why I always do like this interval part. Now 3 pi by 4 means 135 degree. Take it near about 120 degree left value. Okay, now I am substituting in where? F dash of x. Cos 120 degree or plus sin 120 degree. Cos 120 degree, see value you have to find. Cos 180 minus 60. Cos 180 minus 60 in second quadrant. So minus cos 60. Am I correct? Sin 180 minus 60. So that is in second quadrant. Sin is positive. Sin 60. So cos 60 is minus 1 by 2. Sin 60 is root 3 by 2. So we are getting that is positive, which is this implies we are getting positive means increasing. Am I correct? Now I am taking this is 135 to 315. So I am taking x is equal to 150 degree. Okay, this is 135. Am I correct? 150. Now f dash of x equal to cos 150 and then plus sin 150. You should know about this value. This is cos 180 minus 30. Cos 180 minus 30 again in second quadrant. Second quadrant we are getting minus cos 30 and automatically this becomes plus sin 30. Cos this is minus root 3 by 2 and this is plus 1 by 2. Again negative value, that is decreasing. Clear to you? It is quite easy. Try to understand. Just to try to remember trigonometric value, it is quite easy. So this is x is equal to, this is 303 into 7 into 45. 45 into 7 how much? That is 35 plus in 3 remaining, that is 315. So 315 I am taking 330. 330 take it. 330. Now f dash of x equal to cos 330 and then plus sin 330. Sin 330. Okay fine. Now cos 360 minus 30. Cos 360 minus 30 which quadrant? Fourth quadrant. Fourth quadrant cos is positive. So cos 360 same value. So that is equal to, we are getting cos 30. Am I correct? Now this is sin 360 minus 30. So fourth quadrant sin is negative. So minus sin 30. Am I correct? Cos 30 is how much? That is root 3 by 2. Sin 30 is minus 1 by 2. So again we are getting here, that is positive. It is increasing. Are you clear how to do this trigonometric ratio? So now we are getting fx is strictly increasing on 0 to 3 pi by 4 and 7 pi by 4 to 2 pi and strictly decreasing on 3 pi by 4 to 7 pi by 4. Are you clear? So this implies fx is strictly increasing on where 0 to 3 pi by 4 and 7 pi by 4 to 2 pi and strictly decreasing on where 3 pi by 4 to 7 pi by 4. So we have seen two type of question. One is without derivative, how to prove increasing decreasing, and how to find the interval where the function is increasing decreasing, and how to show through argument the function is increasing decreasing. The only three parts are there. It is quite the easiest one. But one thing keep in your mind. Before doing this interval, f dash of x must be factorized form. So whatever the values you substitute in f dash of x, if it is a positive increasing, if it is a negative decreasing. Suppose if you want to show, then you have by argument you have to say why f dash of x is positive, why f dash of x is negative. Anyhow students, take more practice, don't get confusion. See, if you get confusion, there is no solution at all. And without practice, you say, I don't know how to do this topic, I'm getting confusion. The only solution is lot of practice. Do practice and stay blessed and stay well confident. Thank you so much.